it was called Effingham, Illinois.
Oh yeah, I served in Missouri, St. Louis.
Mm. Yeah, me too. Well, at least I transferred there.
Yeah.
My mission dissolved, and I got put into the St. Louis, Missouri mission.
Oh really? Hmm.
I served in Jefferson, and then Moberly, East St. Louis, and yeah, those are probably the big ones that you're familiar with.
Yeah. I served in downtown. It was then called River to Pear, but it was everything east of Grant Street.
Mm,
And I served in University City twice, and Baldwin,
nice.
and Cape Girardeau.
Mm. Yeah, those sound familiar.
Yeah, cool.
That's pretty cool.
Well, should we get started, or do you want
Yeah,
to see if Austin's coming along?
nah, he'll jump in when he can.
Yeah. All right. Sounds good.
Um, okay, I'll take number one.
All right. It's cool.
So, what are the null and alternative hypotheses in the ANOVA? So, the null is that means of the different sample groups are the same or equal, and then the alternative is that at least one or more are different from each other.
Okay. I'll take two. For one of the assumptions of ANOVA, what is the rule for examining the variance of each samples? That threw me off at first, but what they're looking for is that the variance can't be more than 4 times the size. So the largest sample can't be more than 4 times the size of the smallest sample.
Yep.
So if there's a more than a factor of 4, the difference would it wouldn't meet the rule for examining variance.
Yep.
I can do 3.
Cool.
What are the differences between the test hypothesis for ANOVA and the other tests of hypothesis that we have covered to this point of the class, open-ended? Well, this is more than one mean, so the difference between the test hypothesis and
Yeah,
ANOVA.
you have several different sample groups, whereas we only had one or two.
Yeah.
We would either compare them against each other, and we'd find that one is greater than, less than, or equal to, or not equal to. But in this case, we're just trying to find out if there's a difference.
Yeah, so in some ways it's actually easier. You just have to find if they're different. You don't have to worry about two-sided, one-sided, two-tailed, one-tailed, up or down.
It is kind of interesting, though. I mean, like, I don't really find it very useful because it's almost like on par with, there's like a bunch of different directions to go to Utah.
Yeah.
But I'm going to tell you that one is the best.
Yeah.
And I'm not going to tell you which one.
Which one is the best? Yeah. That's what I was thinking. What it tells you is that, okay, there's one of these that has a difference, but you have to go back and find out which one is different.
One of these is not like the other.
Yeah, I guess it's helpful in some way if you have no idea what, maybe it gives you a starting point, but that's all I can think of right now, what it does.
I think so.
Yeah. All right.
I can do the next one.
Cool, thanks, Zach.
I'll read the whole thing. ANOVA, according to William Butler Yeats, she is the Gaelic muse, for she gives inspiration to those she persecutes. The Gaelic poets die young, for she is restless, will not let them remain long on earth. One study designed to investigate this issue examined the age of death for writers from different cultures and genders. 3 categories of writers examined were novelists, poets, and writers. Ages at death for female writers in these categories were given in the women poet data. We would like to determine if the mean age at death is different from any of the categories of the writers used. Significance level of 0.05. To determine that. Design the study was a research question. Says is the mean age at death different from any of the 3 categories of writers? There's a difference between them.
Mhm.
Okay.
State the null and alternative hypothesis. So C. The null would be that they're all the same. The alternative would be that one or more of them are different. Right?
Somebody getting bombed? Yeah. Incoming!
I think that's like cars in the background. It's so dang loud.
Yeah.
There's this one guy that has a trike, and oh my gosh, I know when he's coming.
Oh, wow, I guess so.
Yeah. I mean, I have a pellet gun that I just bought for the annoying birds outside my window at 6 a.m., but I think I'm going to use it on
You might
this
use it
bike guy.
on the trike guy.
Just hope he doesn't wear a helmet this day and just.
You are aware that we're recording,
I'll
right?
take. Yeah. Beware, trike man. If you're watching this, I know where you live. Or at least I know what road you ride on. I'll take 1B.
Cool. All right.
It's basically like the same answer as the first one. So state the null and alternative. The null is that the mean are equal, and then the alternative is that at least one or more are not.
Okay. 2 is collect the data. 2A is describe the data collection procedures. So we've gathered data from North American writers, 3 different groups: poets, novelists, and nonfiction writers. And we're going to stick the data into the spreadsheet and see what comes out.
We have no idea if it's random or not.
Oh, yeah, and we don't know how they collected the data either.
Yeah. Kind of graze over that little gray area.
Right, exactly.
Yeah. All right, so number 3A, in a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. So, yeah. So, there, yeah, that's
Yeah, we're going to just...
summary. And then they used a box and whiskers plot.
Right.
As
Okay.
the standard.
Has anybody been able to stick that information into SPSS and get any valuable data out of there? I was messing around with it before the game. Yeah, I did Excel too, but it doesn't have the box plots and stuff.
You know, it's not really that big of a deal.
I'm not too worried about it.
Well, I already did. I hope you guys don't mind, but I already did the test and got 100.
Yeah,
well, I keyed one wrong, so I got a 94. And I was like, why did I say that? But
oh no.
You don't even need the box plots. They're
right.
useless.
Well, I thought I was being ambitious.
I matched all. Well, I have family in town, so I just wanted to wrap it up a little quicker if we can tonight.
Yeah, that's fine. We can roll.
But I checked all of the values against the answer sheet, and it's accurate. Do you guys know how to use the Excel pretty good?
Yeah.
Okay. It's all you do is you just plug it in, you know.
How about you, Zach? Were you able to find it?
Yeah, I got it. I'm gonna go back and rewatch the videos. Kind of pressed for time tonight too, anyway. So. Yeah.
Okay.
Good though.
All right. Let's do it. What are we down to? Inferences?
Yeah. So what they're asking, what type of hypothesis, and we're doing the ANOVA type.
We have the ANOVA test. That's what we're doing.
With the F test.
Yep. All right. B is the requirements for the test. It's got to be a random sample. It's got to be normally distributed. They have to be independent samples, and they have to have the same variance, even though the variance can be 4 degrees or 4 times bigger.
Yeah. Let's see. Compute the test statistic. So the F statistic is 6.563, and that just comes from the software.
Yep. Have you been able to see that on the software? You just key it in one of the columns or all of the columns, and it spits it out. The degree of freedom is 2 and 120.
I'll share my screen if you guys want to watch how I use the software.
Okay.
So, first of all, this isn't the right data, but basically, oh my gosh, why is my computer not working? Scroll.
Hey Jared, I have the data up. If you want me to just share my screen.
Oh yeah, go ahead.
Okay.
You can kind of show them how it works.
Yeah. Let's see. There. Can you guys see it?
Yeah.
Okay. So column 1. So we're just using the copy of quantitative inference procedures, and we're using the tab 4, which is the ANOVA. And then over here, you just key in the. What is going on with my Excel here? So we have the 3 columns. I think the first one is poets, and the second one is novelists. So that's variable 2, and variable 3 is the nonfiction writers. And so I just pulled the information off of here. Can you guys see the second women poets?
Yeah.
Okay. So you just copy it in here, paste it in there on each column, and then it spits it out over here on the side.
Okay.
Cool.
So the F is that's a little tricky. F is actually the test statistic.
Yeah.
And then it has the p-value and the degrees of freedom. There's 2 degrees of freedom on this. So that's all there is to it.
Yeah.
Cool.
Did you tell them about? Sorry, I was kind of doing something else, but did you tell them about if you have less than, less data samples groups, then you can fill in the thing. Like here, if you look at my screen, and this next one we're going to do for the test, we fill all of the bars.
Oh,
but
okay.
in the one we did earlier, it was maybe like the first 4 or something.
Yeah, it was 3.
And if you don't, first 3, and if you don't erase the numbers that are just like sitting there, then it'll still compute over here and mess up your statistics.
Oh.
So
Oh, yeah.
as long as you delete those that aren't needed, then you're good.
Yeah, start by clearing those out.
Okay.
And it's good to change the labels up here. Like once you change the label, like I don't know if this was Nike or something, it changes it over here too.
Oh.
Oh, that's nice.
That's really good for organizational purposes.
Yeah, absolutely. Cool. All right, should we move on to the quiz? Well,
Sure.
Actually, so the p-value was less than the alpha because the p-value was
Correct.
0.002, and so we reject the null. And then based on the fact that we rejected the null, there's sufficient evidence that one or more of the means within the group are different. We don't know which one.
So someone dies quicker.
Yeah.
And yeah, they're basically saying that the poets are probably the ones that get the axe because they suffer from mental illnesses.
Yeah, but
more likely.
That's a little bit of a leap, though.
Yeah.
Not knowing that
Yeah.
for sure.
Oh, I wrote a poem a while ago, and I'm starting to think about. It was the worst poem ever. I'm gonna kill myself. Probably shouldn't joke about that, but yeah, we can start this test.
Cool, let's do it.
Yeah.
So, you guys can see the answers on the screen, but I'll kind of just go through them so you guys know why. But the first 2 are obvious. Just let me know when you guys are ready, and I'll kind of do the rundown.
Okay. I'm ready.
Me too.
Hey guys.
Austin!
Hey, Austin. How are you, brother?
How's it going?
Good. I got back from. I just took that nursing exam, and I was like, oh shoot, I also have to get online for the.
No worries. We're taking care of you.
Well, yeah, we're just going over the quiz right now. I already did it, so we're just going over the answers and how it was done.
This is 14, right?
Yeah, it bugs me that I keyed that one wrong. Ah, so yeah, just let me know, Austin, when you pull up the quiz, and you, Jared, as well.
I'm ready for you.
Okay,
Yeah.
so just Austin. You ready?
Yeah, I'm ready. Mm-hmm.
Okay, so 1 and 2 are obvious. 3, in an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate that at least one mean is different from the others. So that's true.
True.
And I mean, we all get it, right? That's kind of like the whole idea of the ANOVA, is that one is not like the other.
Mm-hmm.
And that's pretty much it. So number 4, what requirements need to be checked when performing an ANOVA hypothesis? And that's the data in each group are normally distributed, and then the variances are equal in each group.
Okay.
And so that would be B and C. I mean, sample means are all positive. That's not true. There's a couple other things that are required, but they're not in there.
Right. That is just okay.
So to check if each group is normally distributed, you construct a Q to Q plot for each group. And it's very time consuming, so it's a good thing I did this. Let's see, we assume the variance in each group is the same if the following happens. So that's when the largest variance, we're just making sure that it's not 4 times greater than the smallest variance.
Yeah.
So then we, if it's not, then we assume that they're the same. So in an ANOVA, this is kind of interesting. They're saying that, in 2 sample tests, or we're doing it between the pairs, but if there are 3 samples, then there are 3 pairs. So 1 is with 2, 1 is with 3, and 2 is with 3. So you can see that 1 is paired with, each of the others. 2 is paired with each of the others, and so is 3. So how many pairs are there when there are 4? And I already did that if you want to take a look. And I just typed them out.
That's going to be 1. Yeah.
So, yeah, I mean, if you do 4s with everything, you're going to do it with 3, 2, and 1. And then 3s with everything, you already did it with 4, so you only have 2 numbers left. And then 2, you do it with everything, but you already did it with 3, 4, and 1. So, you only have 1 left.
Right.
So you're left with 6. And yeah, I went through and made sure, everyone has a pair, but that would be 6. Well, obviously I did because it's right.
Okay. Did you just type in the number 6?
Yep. Just number 6.
Okay.
So the soccer shoes data, that's what I have up right now.
Oh,
and
that was from the...
Yeah, they want to know what the p-value is. And once you guys input the data, all of your things should be filled, and the p-value is right here, and that's 0.081.
0.081.
Hold on a second.
Is that correct?
Oh, sorry. In this one, they wanted to know what
It gives you the p-value. They
actually gave you the p-value, but they want you to remove the SOX data and then do the p-value. So sorry about that, but all you do is you just go over and you select all that, hit delete, and then it's 0.309.
0.309. Okay.
So you can see it kind of jumped up.
Yeah.
Mm-hmm.
And the next question is, the p-value always goes up when one group is removed, and that's not true.
Yeah, that's right.
Because here, if you guys take a look, if I remove E, it actually goes down.
Okay. So that would depend on the data.
Yep, exactly.
Mm-hmm.
So number 9 is false. 10, what is the highest p-value you get from removing one group? And you just do the process of elimination, remove one at a time, and when you remove C, you get the highest one of 0.448.
0.448.
Yep.
Okay.
Okay, and then when all 6 samples are used, what is the smallest? And there's a cool code if you guys want to use it. So what they're asking is between all the variances of the groups over here, they want to know which one has the smallest and which one is the biggest. And I put that over here, and I just say, so the minimum value, if I didn't have these guys here, I just say the minimum so equals minimum, open parentheses, select them all, and hit enter. And it just finds it automatically for you. And then you hit equals maximum, open parentheses, and select it to find the maximum.
Cool.
So
Nice.
there's that. The minimum for number 11 would be 27.208. And then 12 would be 53.158. Okay, and then 13, the test for equal variances is satisfied. So we just looked at the minimum and maximum. So the maximum is obviously not 4 times greater than the minimum.
Yep.
So that would be true, that the variances are equal. And stupid 14 is I was supposed to say false, but I don't know what I was thinking. Construct a
You mean
Q to
true?
Q plot for each of the 6. Oh, true? Each are approximately normal. So I did say false. Well, okay. So I did mark that right, but for some reason it's true. And I'll show you why I thought it was false. And maybe you guys can come up with the answer why it's true. So I selected the data from A, copied it over into that old, spreadsheet we used forever ago, and look at that. There's no way that's normal.
What?
And that's the same result for every stinking one of them.
Huh. Well, that doesn't look cool.
Go back to your
why
other
is it so far
spreadsheet real
off?
quick.
Do what?
Go back to the original data sheet.
The original data is right here.
But in order for them to even make
Yeah, I
this,
just wanted to. Or I mean, your other one though.
Oh,
Go to the one that has the variances and stuff. I just wanted to see if the standard deviation and means were the same on each sheet, or if it was calculating them wrong or something. Looks like they're about the same. Hmm. Wait,
So
go back and then go back to the QQ plot. Because it shows like 0 to 1. 1 is the max, but why is 1 the max? Shouldn't it be?
That's
is there
weird.
another value on the QQ plot that we're missing? Does it automatically
Maybe.
calculate the mean and the standard deviation?
Mine might be messed up. But it shouldn't be. I
Is it-
mean, it's practically untouched.
Wait, you need to sort it. Step 2 says sort
Sort it?
by sort column 8 from lowest to highest
yeah,
number.
I forgot that crap. Yep. Dang it. I forgot that stupid stuff.
I did the same thing.
Look at that.
Smallest
boom.
to largest.
There we go.
So,
Yeah.
whatever.
Okay.
Never, I'm not going to do that crap again.
You too.
Well, thanks.
Yeah.
So
So
they each
it's
have an
true.
approximately normal pace then.
At least we didn't have to go through each stinking one, together, because that
Right.
took a while just to put them in, without.
Absolutely. Yeah, thanks for falling on your sword for us, Jared.
Yeah, no problem. It's a 94. I'm okay with it. The test statistic for ANOVA hypothesis test is an F statistic. What is the p-value, or is the p-value the area to the right or the left, and that's just from the reading to the right.
All right.
And that's that. So
Cool.
everyone got that, or you want to go back on anything?
I got it.
Sweet beans.
Cool. Thanks, guys.
Yeah. Thank you. You guys have a good night. I guess Thursday we're reviewing for the test.
Sure.
See you guys
All
then.
right. See you next time.
Okay. Bye. I'll send you your stuff, Austin.
Awesome, thanks.
Have a good night.